Hey, what's up, guys? This is Chung here. So today let's talk about this week's weekly contest problems. This is the third one, number 1616. Okay, split two strings to make palindrome. As you guys can see, this one got a lot of downvotes. The reason being is because the example two here. This one is that's a wrong example here. Okay, so I will talk about that later. Basically, you're given like two strings, right? Basically A and B, and you're allowed to partition to split those two strings at any location. Basically, for example, if we have like this A B C D E F, right? A B C D E and F, you can split the strings at any location, and you can even split them into an empty string. Basically, you can split here, 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 and here. Okay, and then it asks you to check. Basically, it just asks you to check with all those kind of different splits, right? Can you find any splits, right? So after split, we have a prefix and we have a suffix, and then of course a B prefix and B suffix. And it asks you to check if there's any A prefix plus the B suffix or the B prefix plus the A suffix, okay, forms a palindrome, right? So return true if it is possible to form a palindrome, otherwise return false, okay? So for example, right, this one is certainly true because with a split empty string and X here, right? So the X is the single letter is a palindrome by itself. That's why this one is is true. But for the second one, actually the second one is really the one that's really it's a bad example because this one it should be true because we have A, B, C, D, E, right? So if we split that at the third index here, right? Then we have F, E, C plus E and F, right? So this is like a palindrome. So this one should be true. Yeah, that's a bad example, by the way. So, and this one, of course, we split uh, at this at this position at the third index. So we have a ULA plus ALU. This is also a palindrome. Okay, cool. So I mean this one, if we do it a brute force, I mean you can do it in the n squared time. Basically, you just try all the possible splits here, right? And then after that you got two substrings from the A and then two substrings from B here. So you just try both of them. That will be because so to split everything, that's going to be a O of n, right? So and to uh to check if the new string is a palindrome is also O of n, right? That's why the total time complexity for the brute force is n squared. But if you scroll down here, so look at the constraints here, right? So the constraints here is 10 to the power of 5. So which means that you cannot do a O of n squared solution. You have to either do a n log n or O of n. Okay. So and so the way of the n here, right? The solution of a log of O n here is because we just simply do this is something like a greedy algorithm, basically, we try to get the palindrome, right, from the start of one string and from the end of another string. For example, from this one, right? Let's say we have a x. So this is A and this is B, okay? Same length, right? So so this is how it works. Basically, uh we check from the beginning of A and then we compare with from the end of B. We check if there's any matching letters, right? Starting from A and ending from B. So we just, let's say if this one has a and B, right? And here that's a and B. Then it means that okay, we have like at least we have we have A, B, and BA already, right? So how many letters left? We only have three letters left in the middle here. So all we need to check is that if these three letters are it's palindrome or not. And but remember that's only for checking from the beginning of A and ending from B here. We also need to do the similar thing for B and A. Basically, we check if the from the beginning of B and comparing with the ending of A, if this one has like a longer palindrome, right? I mean, because this one can have like a longer one. Let's say for the C, B, and A, right? So here we have A, B, and C. So in this case, we have a longer palindrome. All we need to check is we just need to check the remainings, if this remaining is a palindrome. So that's how we do this greedy algorithm. Basically, we do this kind of comparisons for both of the strings, and then we use the ones has the bigger who has the longer uh, the longer index, the bigger index, and then starting from there, we just need to check if any of the string A and B the remain has like remaining strings that can be formed to another palindrome, then we know that's going to be true. Otherwise, it's false. Okay. So and cool. Let's see. Uh, yeah, yeah. So let me start coding here. So this is what I mean here, right? So we have an n. We're gonna define the n here, and then at the beginning, so the first step is to calculate the uh, basically I call it anchor, right? So we have a I equals to 0, right? And then basically while I uh, smaller than n divided by 2, right? Because you know since we're calculating from both ways, so which we only need to calculate until half of the string here, okay? And then I equals to the b n minus 1 minus I, right? So and then we do a I plus 1, okay? And then this is for string A, right? So we need to do the same thing. J to 0, same thing. I actually I can just copy this thing here. Instead, I'm going to use another like index here, right? So J. So here we do it in the opposite way, right? B, J, and A, J. Okay. So now we just need to get the maximum value from those two, right? So now we have anchor here. So whichever is bigger, then we just need to starting from there. We start from there and then we check if the remaining parts, either of the remaining parts for string A and B can form a palindrome. If then we know okay, then it returns true, otherwise false. Okay. So now we have anchor here. Now we have a left and right. So basically I'm having a left, basically the same as the anchor, and the right is the n minus 1 minus anchor, right? Or minus left, doesn't really matter. So right, you know, the way we are checking the palindrome, right? We just compare if the left and right are the same, but when do we stop? So here's a little thing you need to be careful here because you know the palindrome we could have like a ABA, okay, right? So in this case, you know, left and right can both stop at B here. In this case, left and right are the same. But we have another case, right? If the number is even, then we have A, B, B, A. Okay, so if in that case, for that case, the left and right will be next to each other. That's why I'm using this like a left, right minus left is greater than 1. Then we keep going, right? Otherwise, we just stop. As long as the left and right is smaller or equal than 1, then we know, okay, we find a palindrome. Okay, left, right, okay, and that, then we keep removing the left to the removing both the left and right, okay, and then if they're not equal, we simply break it. We simply stop the while loop, right? And then in the end, we simply check if the right minus the left is equal or smaller than 1, right? And then we know, okay, we find a palindrome. We simply return true in this case, right? Otherwise, sorry, not otherwise, but this is only checking the A here. Like I said, I need to check both A and B, right? So very easy. We just need to copy these things one more time. For B, right? So here is B and B, and yeah. So, and then in the end, if none of those is true, it means that we return false, right? So yeah, I think that's it. Let me try to run the code here. Okay, so this one accepted, submit. Did I? What what's going on here? I thought I'm having the same result. Why it's telling me it's wrong answer? Okay. Oh, okay, okay. Hmm. Uh, yeah, this should work, right? Because I just submitted like B and A, J, left. Uh, hmm. Let me see here. Okay, so in this case, I mean I think this is not right. Basically, it has to be smaller than 1, right? Because you know for this one, right? So if these two are the same, right? When this thing is true, so they will be moving towards each other, right? By so basically this will become here and this will become to that. So basically we just need to know the smaller than 1. I think this should work. Let me try this one here. Test here. Yeah, cool. So yeah, I think this this one should be minus smaller than 1 because even though the while this for either of the case here, right? So I mean the the right minus left should be smaller than 1. Actually, it should be even smaller than 0, I think. Yeah, but 1 should also work. Okay. Um, yeah, I think that's pretty much it is, right? I mean, I can see why this one gets a lot of downvotes. Oh, for the time complexity, of course, this is it's obviously like a O of n time complexity because here we have O n, right? So this is n, this is n, this is also n, and this is also n. Basically, 4n is also a O of n. Cool. I think that's it for this problem. Yeah. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.